Hello and welcome to the video. In this session we're going to be looking at processing topographic survey data, the CAD tools and also the surface tools in TBC. If you're unfamiliar with TBC, I recommend going back and looking at our previous videos first, because this video will be a continuation on what we've discussed. In this video we're going to look at, to begin with, the manual processing of feature codes, which can be done. We're going to look at what CAD tools you can use and how they can be used to create data manually against your feature codes. We will also look at the automatic processing of feature codes, which would be a recommended process, and the importance of using an FXL in TBC. Once the feature codes have been processed, we will use CAD tools to edit those codes if there is any edits that need to be made to tidy them up. Finally, in this video, we're going to look at creating surfaces and contours, as well as some of the tools with regards to editing these generated items. My name is Ross McAtamney. I'm part of the technical software team at UPG based in Melbourne. To bring the data into TBC, initially you would drag and drop your job file or JXL or your third-party imported file type into the plan view, or find them from the import options in TBC. The first option here that we're going to talk about is manually processing the data, where once the data's come in, you will see all the points on the screen. You can turn on the feature codes that's associated with those points in the View Filter Manager down the bottom if you want, which could make this process a little bit easier in identifying what codes are where. And then once you've done that, you would simply do a dot to dot. Now I say it's simple, however, each line that you draw, you would need to make sure that you fully define it in terms of what layer it goes on, the color, the line style. However, the CAD tools are there if you want to do it. That time-consuming process can be significantly reduced by using the automatic processing techniques in TBC. This is using the Process Feature Codes option in TBC, where we're using the FXL to define what happens to a particular feature code once it's in TBC and processed. The feature code library will define what layer it's going on, what color, what line style is being used, what symbol, how that symbol is being used in terms of if it's being associated with an attribute. All of that is done automatically when the code is processed. This significantly reduces that time that is being taken if you were to do this whole process manually. Just be aware though, as we've talked about in previous videos, if you have an overdefined or a poorly defined FXL, you're going to have a bad time because you need to edit the data that you've generated in this automation process. The idea of the FXL is to get you 80 to 90% of the way through the drafting process to make sure that all you're doing at the end is the cleanup of the auto-drafted line work and symbology. When you come to processing feature data in TBC, what happens is you would go to the Survey tab, and on the left-hand side there is the Process Feature Codes tool. When you open that tool, what happens is that TBC will show you all the imported data in the project that you are working on. So if you have multiple job files, it will show you a list of all the job files that are in that project. At the same rate, if you have one single job file, it will only show you that one particular job file. In this options menu, you have the option to tick on which particular files you want to process. So you don't have to process all data at once. You can take your time and import and process individual files as necessary. There is also the option within this to specify not to process feature codes that have already been edited. This means that you are not recreating your work once you have edited it if you add more data to a project. Just to note here, I would recommend when out in the field, if you're doing a multi-day job, to have a file for each day as opposed to one file for the entire job. The reason for this is that if something happens to a particular day, you are not going back to redo the entire project. You are only looking at redoing a particular day's work. The other thing to note here is if you key in information in TBC, say through the creation of a CAD point, you can give it a feature code as well. This is handled in this menu as a keyed-in block. It will be handled as a separate line item in the processing feature codes, and you can process this option separately to a processed job. So we are handling all the data specifically to the data that's come in. It is remembering that single source of truth in TBC to make sure that you have one location for processing all your data, and also we are storing, making sure that the data integrity is held. So we are not mixing data types or data options in this process. When you process your feature codes, the first thing that you'll get an option for is the feature code processing report. This shows you what codes have been processed and also what codes haven't been able to be processed in the job. If you have a long list of codes that haven't been processed, it's worth looking at what those codes are and making sure that those codes are correct in terms of are they something that has been collected in the field mistakenly, or is it something that needs to be added to your FXL for future reference? Once you've processed your feature codes in TBC, or sorry, before you process your feature codes in TBC, it's worth tidying up the feature codes. So if you have processed feature codes and they're doing something funnily, or if you are aware that you have some codes that need to be edited, the first point of call would be to go to the point spreadsheet, which is in the home tab of TBC. In here, I would go through and identify any issues with regards to a particular point and make those edits in the feature code. Remember that TBC sees point as is a point-based package and point is king. So in that reference, make sure that your point has the correct information associated with it so that when you process your feature codes, you are dealing with the correct line work and information type. This will also mean that if you have to reprocess the job down the track, when you process that point information, you are going to get the correct edits. If you are editing and tidying up the line work based on the CAD commands, using the tools we're going to discuss a little bit later, if you reprocess that data, that line work will be reappearing and you will have to redo that work. So I would recommend always looking at editing the point number and the point feature code itself to make sure that you're getting the optimal information. The other thing to note here too is that if you want to start using control codes that weren't picked up out in the field and in the office you like to use your control codes, you can add them in here in this point spreadsheet, or you can simply add them in the properties of a particular point and then process the feature codes, and that will improve again what your auto drafting process looks like. The other option for editing data is through the CAD tools. So as we discussed previously, there is the create point, the create line options in TBC. However, there's a whole heap of edit tools which you would expect to have in TBC in a CAD package that TBC offers. There are things like geometry tools where you can detect crossing geometry, matching properties, and those sorts of things. However, in TBC, we have that extended functionality that you would expect for copying, creating, editing, moving, all of those things. As I've mentioned, those tools such as break lines, join lines, best fit, copy, trim, extend, and delete are all there in TBC and ready to be used for if you need to edit your feature data. The other thing to remember too is that it's recommended to address each layer individually so that you're not dealing with multiple layers at the same time. While when you click on the screen, TBC will give you the options if there are points that are overlapping each other or line work to select which particular item you are looking for. I would recommend for simplification to limit your layers to just what you are working on so that you are not dealing with a huge amount of data underneath. In this example here, we've imported some data and we're going to look at the line that's crossing through the middle of our job. In this case, we've gone and opened the CAD commands and we've gone and used the break tool to break the line in the top right corner and the bottom left corner, and then deleted that line out. Now remember, if we reprocess these feature codes, then you would need to redo this line edit. If you went into the points tab and point spreadsheet and you edited the point so that the string at the top is a different string to the string at the bottom, this would have been addressed so that if you have to reprocess the data for any reason, that's not going to happen moving forward. Once you've processed all your line work and you're happy with how your job looks, then it would become to looking at creating the surfaces. I would only create surfaces once you have gone through and made sure your line work is correct. The reason for this is because the line work will be used as break lines within the job. So when you are looking at creating a surface, you want to make sure that your line work is as complete as possible so that you are getting the best representation of the surface that you are wanting. Remember too, once it's in TBC, you can edit the surface that has been generated, but the thing that we would recommend doing is not creating multiple surfaces for the same thing every time you want to make an edit. I would just edit the existing surface in TBC, which there are multiple tools for, which will mean that you're only ever dealing with one surface. You're not dealing with multiple surfaces of the same type. You're not having to delete surfaces out. There is also an option in TBC that in the 3D view, if you hold Control Shift and do a mouse scroll up, it will exaggerate the surface, and down for the mouse scroll, it will flatten the surface out. So this can be used to also highlight some areas where some points may be wrong or some things need addressing. In terms of the surface tools that we have in TBC, by default, the TBC has some extremely long triangles that it will draw. So in the project settings, one of the first things that I would look at in your template generation is to drop the length of the long triangles to something that's more realistic. This can be done on a case-by-case basis as well in the project setting, in the template properties, where you have that same field and you can edit it for that particular template. But at a global level, if you set it in the template or for TBC, then it's not going to be an issue. Once you've done that edit in either the template or in the project settings, that surface will cut back into its more desirable length and will start to look significantly better than it did previously, and you're not dealing with those long triangles. You can trim surface edge triangles. There is a whole heap of tools within the Surfaces tab of TBC, shown at the bottom of the screen here, where you can trim triangles. Now, when you are using the tools in surfaces, most of them will be only functional in the plan view, and you would start from the outside in for trimming surface triangles and follow the properties of the actual function itself. You can also add and remove surface members. So if you find points once you've generated your surface that you don't want included in the surface that you have generated, then you can select that point, and in the surface members you can remove them, or if you want to add elements into the surface later on, you can select that too and add them in. There's also a surface boundaries option. The surface boundaries option will allow you to define where the edge of a surface is, which there is a function that is edge break line that will define that edge break line around your surface once you have the edge happily defined. And then you can add multiple boundaries into a surface to turn on and off the surface function. This will allow you to do things like donut shapes, or to remove the bottom of a building that you may not want to have as a surface because you've got no information with regards to what the contouring or the surface is doing underneath. There's a surface slicer as well, which you can work through and utilize if you need to. Once you have created your surface, the next step I would look at would be to create your contours. Creating contours is a fairly straightforward step. It's at the right-hand side of the Surfaces tab in TBC, and it will give you a whole heap of options. When you create your contours, you would need to specify what the contour interval is, and then the contour frequency, which is the option below that, will define your major and minor contours. In terms of your major and minor contours, it will only be placed on the same layer. However, you can give your major contours or a particular line color and a line style to distinguish them from the minor contours in your job. I would also recommend making sure that the distance between labels is set to 0. This will mean that there are no labels put in your contours once they're automatically generated. You can add labels later. There is a label by crossing, which can be used to neatly put labels in. However, if you put a distance in here, you'll find that labels will be placed all over the place, and for particularly small jobs, this can get very messy very quickly. In terms of the label text style, this is defined in the drafting tab as one of your default text styles, and you can choose that parameter. I would recommend making sure that your text styles in TBC are the correct height and type before embarking on this process. However, if you need to edit these options on the fly, the text will be updated against what that has been done down the track. So all the elements that are created in TBC are dynamic. In terms of your editing of heights in TBC, like I mentioned before, you can add or remove surface elements into TBC. So, into a surface, which would mean that a rise or a point that is erroneous, you can remove out quite easily. Or you can go to the point itself and edit that point so that the instrument height or maybe the target height needed to be adjusted, and that will fix it as well. So if you don't want the point to be included, then you would select no for including surface on that particular point. Or if you want to adjust the height, you can go through and adjust that height and it will be updated in TBC. Just be aware, once you've generated contours, by default TBC will set the surface generation option as automatically updating. So any edit you make, the surface will be automatically updated. However, contours are set by default to manually be updated. So you can manually update contours by finding them in the Project Explorer under the surface that they were generated against, right mouse click and then rebuild contours, and that will allow you to rebuild the contours that are associated with that surface. You can change this setting in TBC by selecting the properties for those contours and selecting automatically regenerate in the properties settings. This is an example of editing of a point here where we've found a point that's too high for the surface based on the points around it. We've gone into the optical spreadsheet and edited the height of the target at that point, which has addressed the issue on the surface, but the contours have needed to be rebuilt. So we right mouse click on the contours in the Project Explorer to rebuild the contours and address that issue. As I mentioned, there are several other surface tools in TBC that to be aware of. The surface slicer can cut through TBC, where you simply draw a line across your surface and you can see what is happening underneath that line in a profile view in TBC. Here we will also show the line work that it crosses over so that you can be fully aware of where it is, as well as the grade that is being represented by the terrain underneath that line at that point. There are cut fill maps if you have two surfaces, so we can handle more than one surface in a project, where you could see differences between a design surface and an existing surface, or two different surfaces, say, that were captured over time. These cut fill maps are like a heat map, and they will show you red or blue by default. However, you can change the colors according to what you want them to be, and there is a whole set of reports that can be associated with how to get data out of TBC to better give you an indication of what's going on with your surface. TBC can also create projected surfaces. So a surface does not have to necessarily be top down. We can create surfaces against any projection, say side on for a building, for example. Another thing we can do is create radial surfaces for tunnels. So there are different surface techniques that can be used within TBC, and it's good to be aware of them so that if you need to use them, you can use them functionally. All these surfaces can be handled, managed, and maintained in the Surfaces tab of TBC. And with that, that concludes our Surfaces video. Thank you for your attendance, and I hope that you found this useful. If you have any questions, please contact us, and we're more than happy to help you through any of the questions with regards to processing topographic surveys, the CAD tools, or creating surfaces in general. We have many more videos to come with regards to other sessions we've been running, and we hope to see you in those soon. Thank you.